Hi everyone. So today is Friday, October 13th. We will start session 5.1 and 5.2. So I hope over this weekend you can work on your homework and also the practice exams. So we have covered everything like 4.4, 4.1 to 4.5. It's gonna be in your exam too. Okay, so do your practice exam and do it multiple times. Next Wednesday we have homework 5 and quiz 3. Okay, everybody? And then the exam is on the Wednesday, October 25th. So if you go to Blackboard, My Grade, you can see your scores. So for your homework, the maximum is 25 points. So if you don't get 25 points, you can do it again and again until you get the full scores, right? If you have questions, feel free to come to see me. I also give you sample solution with the steps, how to solve the problems. And also here, the practice exam 1, if some of you still missed the practice exam 1, please submit those. And exam 1 correction and record. So practice exam should be 10 points. Exam 1 correction and record should be 10 points. If you don't get 10 points, it means you missed something. So the practice exam, maybe you forgot to estimate your total scores. Maybe you forgot some corrections. Okay? For the exam correction, is 5 points. Exam record is 5 points. So if you only get 5 points, you either miss the exam correction or you miss the exam record. Is that clear, everybody? So check your scores in My Grade to make sure you get 10 points. Okay, if not, you can click that, and usually I put some comments and let you know what you missed. Okay, so you can resubmit to gain those points back. So I hope you can get the perfect scores on the homework grade and the perfect scores on the self-assessment. So those together is 10%. You get perfect scores on 10%, and hopefully you can raise your exam average. Okay, everybody? All right, so let's see, 5.1, increasing and decreasing function. And then 5.2, relative extremes. Big idea. Derivative can be used to compute properties of the graph of a function. The location of the extrema of a function is whenever the derivative is equal to 0 or the derivative is not defined. So if I draw a picture, so you can have some function like this, something like this. Then you can see this is a local maximum, right? It's higher than the point near it. This is a local minimum, a relative minimum. And then here, this is a local maximum. And here, we don't have a minimum here, okay? But the derivative can help us to figure out where the point has local max or local, okay? With you should be able to find the extrema of a function by calculating where the derivative is 0 or undefined. Derivative, remember derivative is the slope of the tangent line, right? Look at this point. If you want to see the tangent line, do you see the tangent line is horizontal? Because that means the slope is 0, okay? And here, well, look at this point. Do you see on the left side the slope is like positive, right? On the left side, but on the right side the slope is negative, right? Therefore, at this point, the derivative does not exist, okay? Because your left side limit and your right side limit do not match, okay? So this is the point where the derivative is not defined, okay? Yeah, remember for line, we have m is positive, m is negative, here m is 0, and then here m is undefined. right, everybody? Yeah. And but at that point, the left side slope and the right side slope do not match. So that's why the derivative does not exist. Okay, let's look at some definition. Absolute maximum and minimum. A function f has an absolute maximum, or we can say global maximum, at c if f of c is greater or equal to f of x for all x in the domain. So D is the domain. So if you want to like draw a picture like this, then this is a global maximum, or it's absolute maximum, because it's the highest point of all the points in the domain. Okay, everybody? Yes. So this is a absolute maximum. How about this point? Is this the absolute maximum? Is this no? It's not the highest point of all the x in the domain. Yeah, it's a local maximum. It's not a absolute maximum. Right. And then a function has an absolute minimum or global minimum if f of c is less than or equal to f of x for all x in the domain. Then the number f of c is called the absolute minimum value. Okay, so you usually say f has an absolute max or absolute mean at some x value, and then the absolute maximum value, if you see the word value, it is asking the y value of the point. Is that okay, everybody? So absolute max and absolute means at x equals to some number. But the absolute maximum value is the y value. It's the f of c. Is that okay, everybody? Or the absolute minimum value. If you see the word value, it really means the y value. The y value of the point. Okay. Yeah, so the picture you can think of like this, x squared. Then we have the absolute minimum at x is 0, right, everybody? Yeah, we can draw some example help us to understand. The absolute maximum and minimum values of f are called the extreme values of f. Values means the y values. Okay, when you see the values, it means the y value. Okay, extreme value theorem. A function that is continuous on a closed interval a,b has an absolute maximum value and an absolute minimum value of that interval. Well, because we have a closed interval, which means we include the endpoint, right, everybody? And your function is continuous. Remember, continuous is like you draw the graph without lifting your pencil from the paper, right, everybody? So that's why we always get absolute max or absolute mean, okay? Actually, we get both. We get absolute max and absolute mean. Look at this picture. Absolute max is here, and absolute mean is the endpoint, right, everybody? And here, absolute max, here, absolute mean, there. Or you can have like this picture, because it includes the endpoint. Therefore, here the absolute max is this endpoint, the left endpoint. The absolute mean is the right endpoint. Okay, everybody? So this theorem is very important. The two things we have to make sure. The first thing, you need to make sure your function is continuous, right? If the function is not continuous, then this theorem will be wrong. For example, you can have a function looks like this. Do you see in this case we don't have a absolute maximum? Because it's not continuous. So continuous is very important. And the second thing, it has to be a closed interval. Okay, everybody? If the interval is not closed, Okay, I can have this. Do you see I have an open interval? And here, I don't have the aftermath. I don't have the aftermath. Okay? So the two things you have to make sure the function must be continuous. And the interval must be closed. Then we guarantee to have an absolute maximum and absolute minimum. So far, so good? Okay. Next, local maximum. A function f has the local maximum, or we can say relative maximum at c. If f of c is greater than or equal to f of x, for x near it, near it, okay. Near it means that you can find a small interval, like here, so near it. So you can see, you can find a small bar such that this point, f of c, is the highest point in this small bar. Okay, so it's locally. It might not be absolute maximum. It's a local maximum. Just look at the x values near it. Okay. Yeah, so f of c is greater or equal to f of x for some, and for the x in some open interval. So here the open interval is here. Okay, the open interval containing c. Okay, so this is the open interval. And then the function has a local minimum or relative minimum at c. If f of c is less than or equal to f of x, where x is near c. So you look at this picture. Do you see here? This is a local minimum. Yeah? It's not an absolute minimum because I can find some point that's smaller than that. It's not an absolute minimum. It's a local minimum. Okay? Is greater than or equal to the x near it. You can find an open interval. Okay, and then this is definition of local maximum mean. And then we have the local extreme point theorem. If a function has a local maximum or minimum values at c, then either the derivative is 0 or the derivative does not exist. So the picture is like this. Okay, so like this point, it has local maximum, and then can you see the slope is 0? And then this point we have local minimum, and the derivative is undefined because your left side slope and the right side slope do not match. So the slope at that point is not defined, or you can say the derivative does not exist. Is that okay, everybody? Yes. So we mark the converse is not true. Okay. So if the derivative is 0, f does not necessarily have a local maximum or minimum. For example, x cubed. If f of x is x cubed, then what's the derivative of x cubed? 3x squared. Oh, do you see f prime when we plug in 0? We get 0. So at 0, the derivative is 0. But is this a local max or local min? No, neither, right? So the converse is not true. By the way, you know what is converse, right? P implies Q. The converse statement is Q implies P, right? And then contrapositive is not Q implies not P. Do you still remember logic statement? P implies Q. The converse is like you just reverse them, okay? And you get Q implies P. The contrapositive is you reverse them and then you put not in front of them. You get not Q implies not P. The statement and its contrapositive positive statements are both equivalent. So they're either both true or both false. Okay? Mm-hmm. All right. So, and then sometimes the derivative does not exist, but x equals to c is the point of local maximum. For example, here, right, the absolute value of x, you can see the derivative does not exist, but we have a local minimum. Okay, so 2 points. We have a local max, a local mean, then either the derivative is 0 or the derivative does not exist. Okay, everybody? Yes. Good. Next, critical points. Yeah, we talk about a lot of definition, and then we work on examples. Critical point. Critical point is a number c in the domain such that either the derivative is 0 or the derivative does not exist. So 3 things you need to remember. First is in the domain, and then either the derivative is 0 or the derivative does not exist. Okay, so 3 things you need to check. Is it in the domain? Yeah, you have to make sure that. And then either the derivative is 0 or the derivative does not exist. Okay, good. Now let's look at examples. Find the absolute maximum and absolute minimum for the following function. By the way, open circle means the point is missing, right? Solid circle means we include that point, right? Okay, playing. Look at the first picture. Do we have an absolute maximum?
No, we do not.
We don't. It go forever, right? Do we have an absolute minimum?
No, because there's an open circle at the bottom.
Exactly. So no absolute maximum and no absolute minimum. Okay, Will, do we have an absolute maximum? Yes. Okay, so we have absolute maximum. Tell me the point. 2, 2. Yes. So the x value is 2, the y value is also 2, right? How about absolute minimum? Yes. And what's the point? 1, 1. Right? Everybody? Mm-hmm. Okay, Dylan. The third picture, do we have absolute maximum? No, because of the open circle, right? So no absolute maximum. Do we have absolute minimum? No. No absolute minimum. Okay, see, open circle, solid circle is really important. Page, the fourth picture, do we have absolute maximum? So if I don't put a solid circle there, if you don't see a solid circle there, it means it goes forever. Okay, then do we have an absolute maximum? No. So no absolute maximum. Do we have absolute minimum? No. Right. If I don't put a solid dot there, it means it does not stop. It just goes forever. So no absolute minimum. Okay. Mackenzie, the fifth picture. Do we have absolute maximum? Actually, every point is the absolute maximum and absolute minimum. Because every point is greater or equal to other point, or less than equal to other points.
Would you say one in
You just say every point. You can let the x varies. You can say absolute maximum is x comma 1, where x is all real numbers. You can do that, and it's also equal to absolute minimum. Or you can just say every point is both absolute max and absolute mean. We can also say that. By the way, are you okay with this notation? This means belongs to. It's like a C and then you put a bar in between. This means belongs to. X belongs to the set of real numbers. Is that okay, everybody? Have you seen this symbol before? The belongs to symbol? Yes? Okay. No? If no, it's okay. It's like a C, and then you put a line segment here. It means belongs to. So you can write out, oh, this means belongs to, if you don't know the symbol. Okay. Gabby, we'll look at this picture. Do we have absolute maximum? Absolute maximum? No, right? Because the highest point here is missing. It's an open circle. Do we have absolute minimum? Yeah. What's the point? 20. Yes. So no absolute max, and the absolute mean is 2, 0. Okay, Dong J.
Why would it point one to the absolute?
Oh, okay. Because absolute maximum needs to be is the highest point of all the domain. Do you see I can find a point bigger than that? Then this point is not the highest point. It's not an absolute max. It's also not an absolute a local max. It's not a local max. Because you can see, I look at this open interval, and I can always find some points bigger than that. So it's not local max, it's not absolute max. Is that okay, everybody? But if I have, okay, so if I have something like this, oh, sorry. So if we have something like this, do we have local max? Sorry, do we have absolute max? Don't say an absolute max because we don't know the behavior. But do we have local max here? Yeah, because you can look at the small interval, and this point is the highest point within this interval. Okay, so this is the local max. So this is a local max. Okay, yes. Dante, the last picture. Do we have the absolute max? No. Does it go up forever? So no absolute max. Do we have absolute mean? No, because that point is open. So far, so good, everybody? Yes. Okay. Now, critical points. Find the critical points of the following function. So, critical point, 3 things. Is in the domain. So you need to know what's the domain, right? And then it's either the derivative is 0 or the derivative does not exist. Okay, so remember those 3 things. Okay, first of all, what is the domain? Okay, remember there are 3. So when you find domain, 3 things you need to look at. Do you see square roots? If yes, then you need the things inside the square root to be greater or equal to 0, right? Do you remember, everybody? What's the second thing? Fraction. What do you need? A. Can be 0. Yeah. How about the third one? Ln of A. What do you need? Greater than 0. Yes. Okay, look at this problem. Do you see? Do we have square roots? Do we have square roots? No. Do we have fraction? No. Do we have ln? Yes. So we need the things inside the ln, which is x, we need x to be greater than 0. Is that okay, everybody? That's the domain. And then we need to find the derivative. Okay, derivative. So remember, how do we take derivative from the outside to the inside? Yeah, exactly. Josh, what is product rule? Fine. Mhm. Mhm. Yes. Right, everybody? So each step we just do one thing. The first step we use product rule. Okay, Layla, what is the derivative of x squared? 2x. And then ln x cubic, x squared cubic. What is the derivative of ln x? Yes, 1 over x. Right. Do you remember last class? I asked you to write this on a piece of paper. Look at this every day. Look at this every day. Make sure you can remember them, like your name. Okay, so we want to simplify. So in the last chapter, you're not required to simplify because you just want to find the derivative. But here, you need to simplify because after you find the derivative, you have more things to do. Therefore, here you need to simplify. What can you simplify? The what? Which one?
You can simplify the second part.
Yes.
Then 1 times x squared will be x squared over x, and x 1x squared.
Yes. What? And x squared over x. The x cancel.
Yep.
Yep. Very good. So we get 2x ln x plus x. Right, everybody? Okay. So here, when you simplify, that means you want to factor. Okay? So you want to factor. What is the common factor? X. What's left? We factor out x, we got 2l and x, right? And then plus 1. Okay, see? We factor it. And to find critical points, you have the derivative. And then the derivative is either 0 or does not exist. Okay, everybody? So if you see a bunch of factor and you set this equal to 0, that means your first factor is 0 or your second factor is 0. Is that okay, everybody? Yes? And then, okay, x is 0. We already got the answer. But the second part, 2 ln x plus 1 is 0. How do we solve for x? Blank? Yeah. Yes. Very good. So minus 1/2. Undo the natural log is the same as you want to get rid of it. So the inverse function is the exponential function. Yes. Both sides apply to e. And then e and ln cancel. You get x is e to the negative 1/2. Is that okay, everybody? And we have two answers. So you need to check. Are they in the domain? Is x equal to 0 in the domain? No. So 0 is not the critical point because it's not in the domain. So not in the domain. So our critical point is x equals e to the negative 1/2. We only have one critical point. Is that clear, everybody? So this example tells us after you find the derivative, you set equal to 0 and you found x. But you have to check the domain because the critical point must be in the domain. Okay, everybody? All right. So continue. Look at part B. All right, part B. When I see cube root, I want to make it into the standard form, right? So this is x to the wheel or exponent. 2/3. Right, everybody? Oh, this is cube root. Do we have restriction on the cube roots? No. So cube root, the domain is all real numbers. Right? Square root, then we have some problem. But cube roots, no problem. Domain are real numbers. So domain is all real numbers. Or you can use minus infinity to infinity, or you can use set of all real numbers. Is that okay, everybody? Mm-hmm. Okay, take the derivative. Dylan, what is the derivative? Mm-hmm. Yes. 2 plus 2/3 times x to the 2/3 minus 1 is negative 1/3. Okay, everybody? Mm-hmm. So, we need to simplify. What does simplify mean? Okay, in this case, simplify means when you see negative exponent, yeah, move it in the denominator. Then, because you have two terms, and one term is a fraction, so you need to combine into a single fraction. This is what it means by simplify. If you see a negative exponent. Is that clear, everybody? Mm-hmm. So you have 2 plus 2 over the 3 is downstairs, and x to the 1/3. Because it's negative, if you move it down, it becomes x to the 1/3. Oh, we move it down, it's still cube root.
Yeah.
Oh, but yeah, leave it as 1/3. Okay. Yeah, leave it as 1/3. You don't have to change to cube root. Right. Okay. Actually, I prefer the exponent expression than the cube root. Okay. Yes. Okay. Next, see, you move it down, and then you want to combine into a single fraction. Well, you want to combine into a single fraction, it means you need to look at the least common denominator. Right, everybody? Least common denominator is, so what's the least common denominator? Which is the denominator of the second term, because your first term has no denominator. So we need to multiply the first term by that least common denominator. Is that okay, everybody? So we have the least common denominator then we just need to add the numerators. The first term, do you see the first term? I got 2 times 3 x to the 1/3 plus 2. Is that okay, everybody? When you combine them, you need to find the least common denominator. And then each fraction multiplied by some factor. When you multiply it, make sure you multiply by the top and bottom. Then the effect is like you multiply by 1. You still have equal. Okay, everybody? You cannot just multiply on the top and the bottom. You have to multiply the same thing top and bottom. So it's like multiplied by 1. Okay. And you also want to factor. Okay, so factor. So you want to factor numerator and denominator. Okay, if possible. In this case, can you factor the numerator? 2. Yes. After we factor the 2, we get 3x to the 1/3 plus what? 1, right? All over 3x to the 1/3. Good. So this is what simplify means when you see negative exponents. I know, a lot of work. Yeah, comparing last example. Last example, you don't have denominators and then you only factor. Okay? But this example, you have denominators and you need to combine them and then factor. Okay. Next, keep in mind. Okay, so next, keep in mind if you want to find the derivative is 0, you set the numerator equal to 0. If you want to find the x such that the derivative does not exist, then you need to set the denominator equal to 0. Does this make sense? If your numerator is 0, then 0 over anything is 0. Your derivative does not exist because your denominator is 0. Something over 0 is not defined. Okay, everybody? That's why you combine them into a single fraction. And you factor your numerator and factor your denominator. And now you can set the numerator and denominator equal to 0. Okay? Our numerator, look at this factor. The 2 has no x in it. 2 is the constant, right? So just ignore that. And then the factor, we have 3x to the 1/3 plus 1. Set this equal to 0. This is the numerator. It corresponds to the derivative is 0. Okay, everybody? And the denominator, so we have the denominator, 3x to the 1/3. We set this equal to 0. We solve for x. Page. How do we solve for x? Subtract the 1. So we get -1, -1. 3x to the 1/3 equals -1. Then what do we do? Divide it by 3. So you get x to the 1/3 equals -1/3. Then what do we do? Cube, right? You want to get rid of the cube roots? Then you both sides raise to the power cube. Is that okay, everybody? So your left hand side just get x. Right hand side. Peach, do you? What's -1 cube? -1 cube is positive or -1? -1. And what is 3 cubed? 3 cubed. 3 times 3 is 27. Yes. So we get -1/27. Is that okay, everybody? Okay, Mackenzie, how about the other part? How do you solve for x? And then cube it. What's 0 cube? 0. Oh, see, we get 2 answers. And then you check the domain. Are they in the domain? Yes. Our domains are real numbers. So they are in the domain. Okay, everybody? So both of them are critical points. So they are critical points. Okay. Oh, last one I forget to say. We have to say this is the critical point. Okay, so I say the answer. This is a critical point, but that one is not a critical point. And here both of the answers are critical points. So far, so good, everybody? Yes. So your homework, you also have something like this. If you see negative exponents, that means you need to do more, okay? And remember the steps. Okay. Keep going. Next one, 1/x. 1/x, what is the domain? Dangjae, what's the domain for 1/x? Yeah, x cannot be equal to 0. Yes. And then we know next that we're gonna differentiate. What is the standard form of 1/x? X to the what power? -1. Yes. George, what is the derivative? To the what? Yes. Oh, okay. Do you see negative exponents? When you see negative exponent, what do you do? Move it to the bottom. So this is -1/x squared. Right, everybody? Do you see we only have a single fraction? So unlike the previous problem, we have 2 terms we need to combine. Here, the good thing is we only have 1 term. Okay, so just leave it like that. Yes, everybody? Okay. And then remember, if you have fraction, the numerator equal to 0 corresponds to the derivative is 0. By the way, this problem, let's say -1/27 is here, and 0 is here. We have this critical point. This critical point corresponds to the derivative is 0. So maybe your picture looks like this, okay? And then this point corresponds to the derivative does not exist. So this point you have something like a corner there, and this point you have something with the slope 0. Okay, everybody? Yes. And then here, can your numerator be 0? No. So the only thing it could happen is the denominator is not 0. So that's why the denominator, x squared, set it equal to 0. What is x? 0. So this corresponds to the derivative does not exist. Okay? Exactly. See, it's not in the domain. So no critical point. So far, so good. So it could happen that we don't have anything. Yes. Okay. So this is about critical point. And then next, let's look at how to find absolute mass and absolute mean. Do you remember the extreme value theorem? If the function is continuous on a closed interval, then we guarantee to have an absolute maximum and absolute minimum, right? So now, if the function is continuous on a closed interval, how do we find absolute mass and absolute mean? So step one, find the values of f at the critical points. Okay, so you might have a picture like this. Okay, you might have a picture like this. You find the critical points, and then you find the f values at the critical points. That's step one. And step two, find the values of f at the endpoint. Okay, so you find the critical point at the endpoint, plug in f, find the y value. Then the largest among those values is going to be the absolute maximum, right? The smallest among those values is going to be the absolute minimum. So far, so good, everybody? Yes. So this is how we do it. Okay. Let's look at this example. Yes. We have a closed interval and the function is continuous. Remember, all the functions we learned are continuous on the domain, right, everybody? And this is the polynomial. It's continuous everywhere. Okay, so we know the function is continuous, and this interval is closed. Okay, so step one, find the critical points. So critical points, because we already know the domain for f is other numbers, but we look at the interval from 1 to 5. We only look at the values from 1 to 5. Okay? So we find the derivative. Layla, what's the derivative of 2x cubed? Yes. 6x squared. Next term. Good. Next term. Good. Yes. Do you remember if we have something like this? We want to simplify. What's that mean by simplify? What do we want to do? Factors. Yes. Gabby, can you factor? What's the common factor? 6. Yes. Okay, we factor out 6. What's that? Yes. Good. Can we factor this further? So x squared is x and x. 6 is... Yeah. Then we multiply the outside, and we multiply the inside, and we add them, we get negative 5x. Right, everybody? Okay, we factor them, right? Now, what do we do? Yes. So set them equal to 0. We get the first factor, x minus 3 is 0, or the second factor is 0. Ooh, what is x? 3 or 2. Okay, they are the critical points, right, everybody? So step 1, find the critical points. They are critical points. Okay, so they're both critical points. And then, okay, step 2. We want to find the f values of the critical points and the endpoints. So my critical point is 3 and 2, and then my endpoint is 1 and 5. Okay, 1 and 5. Oops. So we want to plug them into. By the way, if this is -3 instead of 3, do we count the -3? No, because we're looking at the interval from 1 to 5. If -3 is not in there, then you don't look at it. Okay, you only look at the endpoints and the critical points that lie inside the interval. Is that clear, everybody? Mm-hmm. Okay, what is f of 3? Alright, so you need to plug in. Okay, so f of 3 is 2 times 3 cubed. Blaine, what's 3 cubed? 27. Minus 15 times 3 square is, what's 3 square? 9 plus 36 times 3. Okay. What is this? Do you have calculator? What's this? Okay, Will, you're gonna do the f of 2. Dylan, you're gonna do f of 1. Paige, you're gonna do f of 5. Alright. So let me also write it down. So 2 cubed minus 15x squared. X is 2. 36 times 2. The 1 is easy, right? 5, 2, 5 cubed minus 15, 5 squared, 36 times 5. Oh, Blaine, do you get an end number?
The first one, 27.
27. Okay, thank you. Alright. And then, Will, do you get a number? Dylan, do you get a number? 23? Yeah, that one is easy. Paige, do you have calculator? Oh, well, 55. Okay, good. Negative 100? Did you type everything in one step?
Oh, wait.
But try to type everything in one step. Yes. 28, right. Okay, good. So we get 28. And who is the biggest? 5. So absolute maximum is 555. Who is the smallest? 1, yes. So absolute minimum, the point is 123. Is that okay, everybody? Yeah, you find the critical points, and then you just look at plug the endpoint and critical point into that option. And the biggest value will be the absolute maximum. The smallest value will be the absolute minimum. Okay. Happy fall break! I will see you next Wednesday. So do the practice exam and ask me questions. Bye.